Welcome to this R tutorial video where we're going to walk through some of the basics of using the sample command as well as building for loops and using the apply function. So these commands come in useful in a variety of situations when you're working with R. For example, you might want to tell R to do some task repeatedly, like running through every row in your data set and performing some calculation. Alternatively, you might want to run a simulation where you repeatedly draw samples from some population or run some sort of iterated experiment in order to estimate a statistic, for example, the sample mean. So let's start by looking at the sample command. First, we'll just define a vector, call it states, which has 3 character elements in it with names of states in the US. So I created my vector, I see it appear here in the environment, and I can just quickly take a look. Okay, so now we'll use the sample command to simulate a sample. So inside the sample command, we'll define x to be the vector states that we just created, size equals 10, so that means that we want a sample of size 10, and we'll set replace to be true. This means that after each element is drawn in the sample, that element goes back into the vector and can be chosen again as the next element in the sample. So let's run this code and see what this looks like. So I see that I get an output of a vector of length 10 where each element in my vector of states has an equal probability of being drawn every time. So I got Washington, Washington, Washington as the first 3, then California, Washington again, California, Massachusetts. So if we tried to set replace equals false, then we would have to reduce the size of our sample to be smaller than the length of the vector that we're drawing from. So if we run this code with replace equals false, we get Massachusetts, Washington. I can run it again. Massachusetts, California. I'll run it a third time. California, Washington. So note that I'll never get the same state twice if I define replace to be false, because once it's been chosen, it's now essentially removed from the vector that I'm sampling from. So if I were to set the size to a number that's larger than the set of elements I'm sampling from, R would just give me an error message. And so you can try that out if you'd like. So the sample command allows us to draw from some finite set of elements with an equal probability of drawing each element. But one note here is that we can also sample from other kinds of probability distributions, for example, the normal distribution. So in this case, we could use the rnorm command. R just stands for random, and norm for the normal distribution. And here we'll just define n to be 100. So that means I want a random sample from the normal distribution of size 100. So I can run this, and I see that I get an output of 100 numbers drawn from the normal distribution. I could draw a much larger sample from the normal distribution and plot it by using the plot and the density commands and wrapping all that inside brackets. Run this code, and I see that I get a nice, smooth, normal distribution. Okay, so now that we have the sample command under our belts, let's look at another useful function for running simulations, which is the for loop. So the basic idea of for loops is that we're just going to tell R to loop through some operation a set number of times in order to perform a task that might otherwise take a long time to repeat over and over. So let's start with a simple coin tossing experiment. So first we'll just create a vector, an object with 2 elements, heads or tails, and we'll call it coin. So I see my coin object appear over here in the environment. Then we'll create an empty vector toss, which we'll use to store the results of our simulated experiment. Okay, so now we're ready to begin our for loop. So we'll use the command for bracket I in 1:100, and then open up these curly brackets to define the operation that I want to happen inside the for loop. So I here is just the index that we use to index the number of simulations. And what goes on inside each bracket is the operation that will be performed however many times we define in this number here after the I in. So inside these curly brackets, I'm going to define the input into my empty vector toss to be the output of the sample command. So I'll use the sample command where x equals coin, so I'm going to sample from the coin that I created, and size equals 1. So this output will be either heads or tails each time through the experiment. Then, using this arrow, I'm going to store the result of that coin flip inside my empty vector toss, where each result will take the ith element in the iteration through the for loop. So let's run this and see what this actually looks like. So I'll run my code, and essentially what's happened is that my empty vector toss should now have 100 random samples from the coin. So to summarize the results of that information, I can use the table command on my object toss, and I see that I got 55 tails and 45 heads. I could also just look at the object toss to see the results of every iteration through my for loop. Okay, so next let's try a slightly more complicated experiment using the for loop. This time what we're going to do is we're going to sample some information from a population census. So essentially creating a sort of imaginary census data set with some demographic information about people. So we're going to have information about marital status, income, as well as the state that someone lives in. So for marital status, I'll just create a vector with two options, married or single. I'll create an income variable defined as 1 through 4. So you can be in either income category 1, 2, 3, or 4. So I'll create these two variables. And then I'm going to create a matrix this time to store my results. So in the first experiment we used an empty vector. This time, since I'm sampling multiple elements in each iteration of my experiment, I'm going to create a matrix to store that information. So I'll use the matrix command where I'm defining the number of rows to be the number of iterations in my for loop, and the number of columns will be simply the number of variables that I'm sampling. And then I'm going to define data equals NA to fill in this matrix with essentially empty data. So I'll run this code to create my empty matrix. I'll also name the columns of my matrix just to keep things in order. So I'm going to use this C command, which stands for concatenate, C, marital, income, and state, and use the call names argument to apply these names to the columns of my matrix. So I can just take a look using the head command and see that I've got my results matrix ready to go with the names of each of the columns. Okay, so once again we're going to open up the for loop using the command for I in 1:100, open up the brackets, And this time, I'm going to basically be running the sample 3 times for each iteration. So first, I'm going to sample marital once. So this is going to choose either married or single. And the result of that sample will be stored in the ith row in the first column. So essentially that's going to fill in right here. Next, I'm going to sample from income, also just selecting one number, so size equals 1, and store that outcome in the ith row in the second column. So that output will appear right here. And then finally sampling from the vector states, size equals 1, and storing that in the ith row in the third column. So that will be filling in here in the third column of my matrix. So what you see is that for each iteration through the for loop, an entire row is going to be filled in my results matrix. So we can run this code, take a look at the results matrix, and we see that it gets filled in with our demographic information. So for the first row, this imaginary individual has married status of married, they're in income category 4, and they live in the state of Massachusetts. Okay, so a final note that I'll mention in this video is the apply function. So the apply function is useful for summarizing large amounts of data or applying a function over a data set that you might have. So let's take a look at one example using the results that we've just found. Basically what I want to do with the apply function is use it to summarize the information from the results that I just created for my results in experiment 2 and use the table command to summarize each of these columns. So I'm going to open up the apply command. Big X equals results, so that's the data set that I'm interested in. Margin equals 2. That means that I want to summarize information over columns. If I set margin equals 1, I would then be summarizing information about rows, but I want information about the columns here. And FUN equals table. That specifies that I want the table command to be applied over the columns in the results matrix. So let's run this code, and we see that what we get is information about the for loop experiment that we just ran. So $ marital, so for the column marital, we see that we had 60 married and 40 single. For the income variable, we've got 23 in category 1, 33 in category 4, and so on. And for the state variable, we have 39 in California, 29 in Massachusetts, and 32 in Washington. So the apply command is just another way of summarizing information that can be useful when you want to summarize information over multiple columns of a data set. So I hope that this has been useful, and good luck getting started with using the sample command and for loops. As always, remember that you can use the help function to find more information about the arguments to go into commands and to find more working examples.